Okay, homework for section 7.3. So the economic dynamism, which is the index of productive growth in dollars for a sample of countries that are designated for the World Bank as middle income, are in the table below. Okay, countries that are considered high income have a mean economic dynamism of 60.29. Okay, let's write down. U is equal 60.29. That's average of population, right? Because we are talking about all countries that belongs to that World Bank is serving. Do the data show that the mean economic dynamism of the middle income countries is lower than the mean of higher income countries? Test at 3%. Okay, let me see. We're going to test at 3%. All right, let's start answering the questions. So this is our table and we will work with the table, but let's start at the beginning. So what is the correct parameter symbol for this problem? Since we are talking about average, right? Income have average economic dynamism, and we need to find out the mean, show that the mean economic dynamism and blah blah blah. So mean, which is going to be our mu. Okay, this is going to be our answer for first question. What is the wording of the parameter in the context of this problem? Let me see what is given. In our case, it's going to be the mean economic dynamism of all middle income, right? Is if they say in 24 randomly selected, that's going to be not for population. Mu it's for the population, not for sample. But if you pick 24 randomly selected middle income countries, then it will become sample. So everywhere we see 24, we skip it because the average of population is going to be for all middle income countries. So the mean economic dynamics of all middle income, yes, the dynamics of all middle income countries, that's correct. All right, fill the next. So what do we get? Our average, we already know 60.29. So do the data show that mean economic dynamism middle income countries is lower? The word lower does not hold equal sign. It just holds less equal, less, and therefore, as I mentioned previously, I can repeat again. It's not a big deal. So every time when we have any symbol of inequality without equal sign, that's going to be our alternative. Only null hypothesis is going to hold equal sign. It's going to be either equal, it's going to be less, equal or less. It's going to be, okay, hold on. Equal or less, it can be greater or the equal. So wherever equal sign is, that belongs to null hypothesis. But because it says lower, so in our case it's going to be alternative hypothesis, and the complement it should be greater or equal. But since we are usually testing null hypothesis on equality, we just simply can put equal sign. This textbook, this material uses null hypothesis equal. But I can assure you the complement of less it's going to be greater equal, so it's not going to be problem. But in this material they always use the equal sign, and I can understand the reasoning, because we always start testing null hypothesis. It's very important to remember. We always start testing null hypothesis because we never start the testing with no trust. So we trust that equal sign is the truth. Okay, that's why. All right, so let's put this null hypothesis case, because it says low. So in this case, we are testing mu, right? Because it's talking about average. And the claim is it's less than, right? And how much was 60.29? 60.29, okay. And hold on, how can I? Okay, 60.29. And accordingly on null hypothesis, it's gonna be left mu is equal to 60.29. Okay. Next, some assumptions we are going to pick. So since, let's see, what kind of information? The information, it's going to be our quantitative. Why quantitative? Let's go back and talk. So a growth in dollar amount, it's a quantitative, right? So therefore we pick quantitative information. Quantitative information was called from each subject. What condition do we need to check? Okay, so because it was collected from each sign, what condition we need to check? First condition is if it's greater than 30 or less than 30. Sample size. Why do we check it? It's very important because if it's n for normal distribution, if n sample size is greater than 30, we are going to use one method, which we call z-score method. If it's less than 30, then we are going to use t-score method. But both cases are for normal distribution. Okay. Also, if sigma is unknown. So sigma is unknown in this case. If it's sigma unknown, okay, that's we're gonna check. And we also want to know that it's normally distributed, which means no outlier in the data. That's also will give us sign that it's a normal distribution, because if we have outlier, that means the data are skewed, right? Okay, next. We need to check those assumptions. So is sigma indeed unknown or not? Sigma is known. I don't think sigma is known. We wrote out all information and there is no sigma here. So no, we put it's not known. Okay. Next, question number 2. Given the following modified box plot, okay, if using a screen reader, use technology to generate a modified box plot and answer the questions. Okay, it's generated already. So we need to find out, are there outliers? When I'm looking these outliers, possible outliers, 33.77, 18 and 55.2712. They are on equal the distance far away from the main box plot, correct? Therefore, we say no, there are no outliers. If one outlier that would be much further than the other, then we would decide that there is outlier. But this way, we have the equally same tail for our normal distribution. So, and what does that mean? No, and our modified box plot shows no outliers. All right. How much is n? Well, n, we need to go and count it. Let me see. I guess we can count if we copy and paste to our Statcrunch, because we have to copy anyway to continue other data information. So once we copy and paste, the last number will give us sample size. Copy. Here is my Statcrunch. Now, okay. How I was copying? Yeah, here is edit. I mean pasting here. Okay. And insert. I don't remember we were using white space or tab. I think it's tab. We'll see. If not, then we come back and pick white space. So we're good. The only thing is economic dynamism. I'm going to move into title, right? Okay, cut. I'm going to paste here. Okay, I put economic. And here, dynamism. That's good enough. Okay, and I'm going to take the last digit here and move to the first one that is empty. Okay. It's a little bit difficult to work on iPad. Okay, cut. And I'm going to paste on the first one. There we go. So how many we have? Let's scroll down, 24. Okay. So where is it? 24. And 24, we are checking our condition. We are using z-score the test statistics if we have greater than or equal 30. But we have 24, which is less than, right? It's less than 30. Okay, let's check. For now, we answered quite a few questions. This is correct, this is correct. Everything here is correct. Okay, good job. So, next, name. No, is it reasonable to assume the population is normally distributed? Obviously, yes, because we didn't find any outlier. Yes, since the normal probability plot is roughly linear with no outlier. Okay, moving to next one. named the test. Okay, what do we have? The conditions are met to use. What do you think? T-test or z-test? Z-test. I say t-test. Why? Because it's normally distributed, again, with no outlier, but the sample size is less than 30. Therefore, we choose t-test. Okay? At this point, we are doing test statistics, and we're going to choose t-test statistics. So, the symbol and value of random variable on this problem are as follows. Okay? So, we are going to choose for test statistics, always to do test, since our hypothesis test is mu, a mean of population. That's mean the test statistics we are doing for mean of the sample, x bar. Okay, how to find x bar? We are going to Statcrunch. Since we are given data, I'm going to stat. T-stat, see here, T-stat. One sample, because we have only one sample. And I'm using with data because I have raw data, right? If I would be given the average of the sample and all other data I need, then I would use summary. But here I'm choosing data because I have raw data, right? Okay, selecting column, I'm going to select economic dynamism. Yes, we have to put our hypothesis test sample size. It was 13, I believe. Yes. Yeah, I think it was hold on. No, I'm sorry. 60.25. Yeah, that's right. So 60.29. That was our mean for the population. And alternative was less than, remember? Less than, and automatically 60.29 came through. All right, we have all this, clicking compute. There we go. Here we have everything we need. Sample mean, and then t-statistics, and then p-value. So sample mean is, in our case, is going to be 44.9305, blah, blah, blah. Can I copy this? Let me see if I can paste it. Copy. Okay. Where is it? Test statistics. X bar is equal. No, it doesn't let me. Okay, let me see. 44.9305. 44.930587. Okay. $44.9305. Am I right? 87. Okay. Since it doesn't say round up, we have to put all the last round value to 6 digits. Nothing to round because all together is 6 digits. But 44, I didn't put point. There we go. 44.930587. Okay. Next. The test statistics formula set up with numbers that as follows. Okay. We can find the test statistics already. We know the answer, and it's here. Statcrunch. T-stat, see here, negative 13.294482. But this word problem is enforcing us to go to show us the process of calculation. We will do that. It's not a big deal, but I can write down it was, here is the t-test. It was negative, right? Okay, hold on. Gee, more numbers are coming up. All right, negative, we had 13.29. Okay, so, and this number we are getting how? Here is formula, t is equal x bar minus mu over s divided by square root of n. All right, how much is our x bar? The sample mean is 44 point, let's write down here. 44 point, let me open again, 93 0587 0587. We need to subtract our mu. Mu was 60.29, right? That was easy number to remember. If we need to divide by S, it's a standard deviation for the sample. It's right here in the formula. See? S over square root of n. So here has to be S. How are we going to find out? Standard deviation for the sample is not given, nor standard deviation for the population. We are going to use this calculator, which obviously we are going to, it's going to be under the video. So I need the data, copy the data here. There we go, copying. And then I'm going to paste, where is it? Here. Let me clean whatever they have here. Okay, now we can paste. All right, and since we need to find out S, which is our sample standard deviation, so we choose not the population, but sample, okay? And click calculate, and we are getting, where is it? S, here it is. Our S is 5.6599. If I round it up to 6 digits, it's going to be 01. So 5.659901. Okay. Let's go for it. Where is it? Here it is. 5 point, how much it was? 659901. Okay, and we divide by square root of n. Our n was 24, so we write down 24, and the math, it will do itself, square root, and that's it, square root 24, and we get negative 13.29. I don't need to do all this calculation I placed here because we got it from Statcrunch, and it says negative 13.29. Next, obtain p-value. Okay, p-value, we are going to our, let me see how many decimals they want for p-value. Okay, it is possible when rounded, the p-value is 1, 2, 3, 4 digits. Okay, 4 decimals. All right, let's go. Here is our p-value. So less than 1, 2, 3, 4, 0.0001. All right, let's put it there. 0.0001. This is our p-value, right? Now, we have all that. Now we are going to make our decision based on p-value. Remember here, we will need this when we said that 3%. What happened to that 3%? I wrote down. Let me check it here. At the very beginning, remember, it was test at 3% or something. Let's find it. Yeah, test at 3%. See it? The last sentence in the word problem at 3%. So we are going to compare our p-value to 3%. Okay, let's write down. So our p-value is going to be less, right? Okay, less equal. Since our p-value less equal than 3%, right? Where is our 3%? Here, which is going to be 0.03, 0.03. Okay, so every time when we have our p-value less than testing percentage, then as a rule, we are going to reject null hypothesis. Make a note. If p-value is less than testing percentage, then we reject null hypothesis. If p-value is greater than testing percentage, then we fail to reject null hypothesis. See? Fail to reject. We never say accept, don't accept. We say reject or fail to reject. Fail to reject, it's the same accept, right? Okay, we are good. Now we are going to do conclusion. So what conclusion we can draw? So there is, okay, significant evidence because it's less than. That means, and we reject null hypothesis. So there is significant evidence to conclude that, let me see what we have. It should be the mean economic dynamism of all middle income countries is less than 60.29. Because our claim was alternative hypothesis, right? And because we had here what? This was our claim. Null hypothesis less than 60.29, right? Now, since we reject this one is complement, so but that's mean here we fail to reject or we accept it. Fail to reject. Since the synonym is accept, that's mean indeed we agree that it's less than 60.29, okay? So, what was that? Let me see. So there is significant evidence to conclude that the mean economic dynamism of all middle income countries, of all, right? Because we are dealing with population. Mu is about population. That's not what I wanted, of all. Okay, countries, middle income countries, is gonna be what? Less than, right? The claim is true. Less than, how much? 60.29, because that was the average of population and claim. 60.29. Okay, let's submit. And get to second half. Oops, what is this? X bar? Well, let's go back and check. X bar we didn't even calculate. We took it from 305, hold on. 5930587. Well, yeah. Three zero 587. I'm going to open the answer. 5888. Where from they got it? Well, that's what Statcrunch gave us. Okay, one more time. Just because there is slight difference of these two numbers, so results, if you face something like this, just text me and I'll give you credit for this. All right? Okay. So anything else? Well, accordingly this one also, so 8. Okay, this is also correct. Everything else is good. Okay, we're good. Next question. Seems to me next question is identical to the first one. Therefore, I'm not going to solve it again. But I would like to invite your attention on the following things. When you're gonna put down null hypothesis or alternative, always watch out what is given, alternative or null. Let's say in this case, I'll help you to figure it out so you can understand, would feel more confident. In this problem, it says that the mean pulse rate after running for 1 minute of female who don't drink is 97 beats per minute. Okay, so 97 beats per minute. When it says is, that means it's equal sign, right? In this case, it's gonna be equal sign because let me open all answers so you can understand. Let me see, where is it? Here it is. So mu, yeah, equal and not equal, obviously. Oh, why is it greater? Let me see. Let me read here. 1 minute of female who do not drink is 97 beats per minute. Do the data show that mean pulse rate of female who do drink alcohol is higher? I didn't finish reading. The question is asking, does that mean that the average pulse rate of the female who do drink alcohol is higher than the mean pulse rate of females who do not drink? This is, since it says higher, this is why we use greater than, and because equal sign is missing there, that claim is going to be alternative. And now we always go with equal sign. That's one thing I want you to watch. The other thing also, yes, based on sample size, where do we have it? Based on, here it is, how much is sample size here? 36. So remember what I said, if sample size is less than 30, we are going to choose t-score. But here we have 36 in this case, in second problem. Therefore, you are going to choose, let me close it. So if assuming I had 36, then I would choose that. And then instead of t-test, I would choose z-stat and one sample. Okay, with data, because we are working with data. And this way also mu, I would put our mu, I don't know how much it was. And you can place the mu, how much it is, equal and greater than. And once you click compute, here it's going to work with mu is 0, but that's okay. Select column, okay. Me select column, I forgot. Okay, complete it. And here we got now for z-score hypothesis test. Now these data are not true because I didn't place the average mean for population. It stays there 0. So you just place your average. How much was average for this one? 97, yeah. So if you place 97, you will get, here it is, it might as well let me finish it. Yeah, but data are different. Okay, never mind. You have to copy and paste the data that is given in your problem. And that's the second thing you want to pay attention. And the third one, also very important one, once you get p-value, you want to compare to percentage of the test. I think in this case was 7%. Let me see how many percent it was. Yes, test at the 7% level. So if our p-value, you can take a note of these 3 important things that will guide you the direction what to choose, t-test or z-score test. So anyway, if p-value less than given testing percentage, then we reject null hypothesis. But if p-value is greater than a given testing percentage, then we fail to reject null hypothesis. Okay? Also, what else? I think that's it. And when you draw conclusion, if you reject null hypothesis, then you support practically the claim of the average, of the mean. If you fail to reject null hypothesis, then you don't support or you reject the claim, okay? As a result, that's when it says state a conclusion, okay? So let me bring example. One second. Yeah, let's assume our p-value, let me write down here. Our p-value, let's say, is greater than testing percentage, right? So hence, we fail to reject null hypothesis, right? So in this case, then we accept the claim. If it says more than, then we agree that yes, indeed, it's more than. If it says less than, then we indeed agree that it is less than. But if the p-value is less than testing percentage, then we reject null hypothesis. Okay? And you draw conclusion accordingly. All right. Moving to next question. Let me see what's happening in question 3. Question 2 is same. So let's see. I want to get rid of this keyboard. Okay, here it is. So question number 3, it is the same thing. So you already know how to do it. If you get stuck, don't struggle. Please contact me right away. Okay, number 3 also the same. So 2 and 3 are the similar problems. So moving to number 4. It is the commonly believed that the mean body temperature of a healthy adult is 98.6 degrees Fahrenheit. You are not entirely convinced. You believe that It is not 98.6 degree Fahrenheit. You collected data using 35 healthy people and found that they had a mean body temperature 98.24 degree Fahrenheit with a standard deviation of 0.92 degrees Fahrenheit. Use a 0.05 significance level to test the claim that the mean body temperature of healthy adult is not 98.6. Okay, so it says use 0.05 significance level to test the claim that the mean body temperature is not meaning not equal, which is going to be mean is not equal, average is not equal, and accordingly the null hypothesis is going to be mu equal. It's a complement, right? And how much it's going to be? 98.6. We are testing 98.6, right? Point 6 here, and here is also 98.6. Okay, so next, what type of hypothesis test it is? So hypothesis test, actually I'm going to place a lecture also so you can understand. Hypothesis test identified based on alternative, which is in this case H1. So if we have greater than, it's going to be right tail. If we have less than, it's going to be left tail. If we have not equal, it's going to be two tail. In our case, it is going to be two tail. Okay. Next one. What is the significance level? Significance level was 0.05, right? Okay. 0.05. Okay, now calculate test statistics. Okay, we are going to go to Statcrunch. Let me see. We are given, let me write out everything. What do we have? And you can write with me as I speak out loud. So we are testing our mu 98.6. You are not entirely sure. You believe that it's not 98.6. You collected data using 35 healthy people. That's the sample size. N is equal 35. I'm writing here on piece of paper so I can enter. Once I have it, I will put on in the note also, so you will have it. N is equal 35. Okay, 35 healthy people, and found that they had a mean body temperature 98.24. Since these 35 people have the mean temperature, that's going to be X bar, average of sample, X bar 98.24. Okay, standard deviation, because it belongs standard deviation of the sample, we put letter S, not sigma. S is 0.92 and 0.05 significance level. I don't know if it will ask, but we will do it. So let's go our Statcrunch. We close it. Okay, we need to delete this because we don't need this anymore. Now this one we need to clean. Actually, if I choose with the summary, then I don't need raw data. So let's choose it. Stat. Our sample size was how much? 35. Oh, 1 second. I promised to write down on the note. Here it is. We have. So our sample size is 35, which means we are going to choose Z-score, not T-score, right? It's more than 30. X bar is 98.24, and then S sample standard deviation 0.92, and that's it. Significance level 0.05. Okay, moving to our Statcrunch. So 35, I'm choosing Z stat, and instead of data I'm using summary because we are not given raw data, we are given summary. See, and X bar S, that's a summary. So sample mean we have 35. Since once I play summary, then the Statcrunch will not go try to pick up the data that I left there. It will work with the summary, okay? So it doesn't matter that I left it there in the Statcrunch. So standard deviation 0.92. Sample size, well, okay, sample mean, not sample size. That was sample mean, 98.24. Okay, let me zoom a little bit. Seems to me it's not seen. Okay, sample size is 35. All right. So hypothesis test, it was how much? 98.6. It's claiming 98.6, right? Let me double check. 98.6, yes. So equal, and then this one is not equal 98.6. And we are good. So we're going for calculation, compute. Here I have it, compute. There we go. We have here, so sample mean, we get 98.24, it copied there. So test statistics. We are interested in test statistics, and that is negative 2 point, let me write down, negative 2.3149877. And p-value also, let me write down, might as well, 0.0206, we might need it. Okay, back to our homework. So where are we? Test statistics, here it is. It's gonna be 2 point, negative, .3149 877. Let me double check. I'm hesitating. 3149 877. Okay. 3149 877. Okay. Now p-value, and we already have it, 0.02. So 0.0206. Okay, does it say 4 digits? Okay, 4 decimals. Okay, we have it. All right. Next, what we have? Do we reject null hypothesis? Our p-value 0.02 and our significance level is 0.05. 0.2 is less than 0.5. Oops. Because it's less than, then we reject null hypothesis since p-value is less than significance level. Here it is. Okay. Now select statement below. So if we reject null hypothesis, right? That's mean what? We support our sample data, support the claim that mean body temperature is not 98.6, because our claim was it's not 98.6, right? Where is it? The sample data support, here it is, support the claim that the mean body temperature of a healthy adult is not 98.6. Okay, let's submit. Let's check. It's correct, correct. What is this wrong here? Didn't we do 0.0206? 0206. Okay, let's see what's happening. This is absolutely wrong. Okay. But the bottom line is it's not going to prevent us from to draw right conclusion. Again, guys, if you see such mistakes, contact me right away, okay? All right. So we are good. And question number 5. It's similar to number 4, actually. See how many pounds, test statistics, p-value, and draw conclusion, and so forth. And the same way is question number 6, significance level. Yeah, it's already same thing. What is 7? Find critical t-value. Okay, we will do question number 7. So what do we have in question number 7? Find the critical t-value for a sample with n is equal 24. Okay, alpha equals 0.03 for left tail test. So we need to find the critical value. So we are going to our Statcrunch. So if n is 24, we need to use, since it's 24, it's less than 30, then we are using t-score, right? More than 30, we would use z-score. So using 24 and degree of freedom, it's going to be -1, which is going to be 23, right? Just to remind you, we always have, hold on, my pen is not working, looks like. Okay, tap 2. Okay, connected. We're good. So if n is 24, then degree of freedom is 23. I'm clicking on stat, calculators, and T. So what do we have? And I'm clicking on standard because I don't have between, so it's going to be standard. Degree of freedom is going to be 23 because 24 minus 1, 23. And since it's left tail, so we leave it x is less equal and put 3%, it's going to be 0.03. Okay, and once I click compute, and here we are getting negative 1.978. Okay. Excuse me. Negative 1.978. Here it is. Let's submit the question. Okay, we got it right. Now, here is the thing. Let me explain you something. Because we had left tail, right? Which is going to be here, 0.03, right? And z-score, it's going to be here, negative, right? But if it would say to the right, 0.03, then I would have it here. And this area would be 0.03, but z-score would be positive. In this case, the easiest way would be find 0.03 to the left, okay? And then just flip the sign. Let's say, for example, in this case that we have negative 1.978, if it would say the same condition, and alpha is 0.03 and right tail test, then you would get positive 1.978. Why? Because, no, that's what I wanted. These areas are the same, equal. So we take 0.03, get negative z-score, so we flip. If it was negative 1.978, this one will be positive 1.978. Let's test it, try it on the where is it? Oh, here should be. So on Statcrunch. I'm going to put greater than. So let's see how much it's going to be. How much did we have? 0.03 it should be. 0.03. Okay. Compute. And there we go. And as you can see, we got positive 9.78. Why? Because just like I said, the areas are the same. And you just got for left tail negative sign, and you flip. If it's right tail, then you flip to positive. And if it would be between, then you would click here between, okay, and plug it here between, or if it's 0.03, again, let's assume, and we are getting negative 0.038 and positive 0.038, and that's what you would put. Okay, so this is number 7. Moving to number 8. Okay, so what do we have in question number 8? So we're performing a left-tailed z-test. Okay, so we have alpha that's equal 0.1. Alpha meaning this is our alpha, it's percentage, this tail, that's rejection area, okay? So alpha equals 0.1, all right, let's write down. Okay, which means 10%. And test statistics Z is negative 1.43. Negative 1.43. Okay, well, let's find Z critical. This is what we call Z critical. Okay, so we are going to our calculator. Alpha 0.1. Okay, we have it already here. 0.1. Let me click calculate. Okay, and we get Z is equal negative 1282. Okay. This is Z critical, negative 1.282. This is our Z critical. Now let's compare to what we have. Z is equal negative 1.43. So it's gonna fall somewhere here, right? Less than. So it's falling in rejection area, correct? So from here we can say that we are rejecting null hypothesis. Here it is, we have it there. We reject null hypothesis. Let's submit the question. Okay, submission rejected. So hold on, it doesn't want to accept submission. Okay, now we should be able to do it. Oh, negative 3.30. Ah, it changed the problem. Well, we'll do it again. Alpha equals 0.05. Not a big deal, practicing. And Z was negative, how much? Negative 3.33. Okay. Let's clean this. We need to find our Z critical. Okay, we are going here. So 0.05, right? Oh, right? So Z critical negative 1.645. Negative 1.645. This is our Z critical, which means this is our the negative 1.645, and negative 3.33. So negative 3.33, it's falling in rejection area, right? Because it's less than our Z critical. Therefore, if it's less than, then we reject our null hypothesis. There we go. Perfect. Now, instead of Z, first of all, let me invite your attention on something. This is going to be, okay, this is going to be your Z critical. That's the one that you need to find from the calculator based on this given alpha, say in this case 0.05. And the Z-score that is given, negative 3.33, you are figuring out where it is located based on how much your Z critical. If negative 1.645 this, then negative 3.3 is falling somewhere here in rejection area, because alpha area is our error. That's the rejection area, not acceptable area. Okay? Now, this is about Z-score, but sometimes there can be also T-score. Let me see if I can get T-score here. Okay, no, let me jump to answer. Every time it's jumping to the beginning. There we go, T-score. Let's do also with T-score, so you would be fine. So alpha equals 0.005. Alpha 0.005, so 2 zeros there. Okay, and T is negative 3.29. Negative 3.29. What tail we have? Let's find out. Left tail. Okay, so T-score, we can do it on our Statcrunch. So clicking Stat, calculators, and taking our T. There we go. So our alpha is, since we don't know Z critical how much it is, so we're cleaning, but we know our alpha is 0.005, I believe. 2 zeros, I will check it. And let me see, 2 zeros. And what else did we have there? Degree of freedom. It doesn't give us degree of freedom, how much it is. I mean, it should be in the word problem. Let's check it. Oh yeah, here it is, size of 33. Okay, which means degree of freedom will be 32. 32. And because it is left tail, there we go, left tail, then I don't touch anything, it's going to be here. If it would be right tail, then I would change it on right tail. Or if it would be two tail, I would click here on between. And I would get here two tails, I would get both of them. Okay, but right now I am doing standard. So it's 32 in 0.05, 0.005, and we need less than for left tail and click compute. And we get negative 2.738. Okay, negative 2.74, negative 2.74. So since this at negative 2.74, this is T critical. And where is my the T score? It's negative 3.25, so it's somewhere here, negative 3.25, which is falling in rejection area, and that means we do reject. So Let me reject it with big pleasure. I'm joking. Okay, submit. Bingo. We got it right. Okay, so I'm done with 7.3. You will work, while you will work with 7.3, I will work on recording the next section, which I believe it's 8.1. Okie dokie.